I want to welcome you to our Stata online training for research analysis. This training is exclusively designed for lecturers, researchers, postgraduate students, and professionals who want to unlock the power of Stata for statistical data analysis. If you have not known our company, Projected Consulting assists individuals and organizations to implement the latest technology tools in business intelligence, data analysis, and project research development. We can also deliver classroom or online training experiences on each of the following courses. For example, we have data analysis with SPSS, 𝐒𝐕𝐈𝐄, Stata R, Python, MS, including advanced Excel. We also handle thesis writing, research consultancy services, proofreading and editing, data analysis, and plagiarism testing. My name is 𝐤𝐤𝐒𝐒. I'm the presenter of this training. I also want to recommend some of our books that will help you get to understand statistical data analysis much better. We have SPSS data analysis, we have econometrics data analysis with 𝐒𝐕𝐈𝐄. So I want to encourage you to visit our online platforms. We have the books in Amazon. You can visit and get the book on Amazon. Today's class, we're going to focus on correlation analysis, interpreting the outputs of a correlation analysis, including ANOVA analysis and regression analysis, and how to interpret the outputs. Okay, today we are going to look at correlation analysis. We stopped at correlation analysis last time, and I explained to you how to interpret the correlation between the weights, the IQ, and the age. I also told you that the correlation between IQ and the weight has a correlation coefficient of 0.2037 with a p-value of 0.4176.
Okay.
So you can see that from here, weight against IQ has a correlation coefficient of 0.2 with a p-value of 0.41. What that means is that the correlation is a weak correlation between the two variables, since the correlation coefficient is less than 0.3, which is the threshold for strong correlation.
Okay.
Now, the direction of relationship is a negative relationship since the coefficient is negative. This minus here attached to the correlation coefficient shows that there is a negative correlation. What negative correlation means is that if weight is increasing, IQ will be reducing. So they have inverse relationship.
Okay.
Then we also conclude that there is no significant correlation between the two variables since the p-value is greater than 0.05. So
Okay.
with this explanation, you will also apply the same knowledge when you want to interpret between age and weight, and at the same time age and IQ. So that's the concept of how to interpret the correlation coefficient or the correlation relationship between two variables.
Mm.
The next hypothesis we have here is hypothesis number 5. The hypothesis number 5, we have, do intelligence score of women who are depressed differ between the levels of depression? Now we want to compare the levels of depression, which has about 4 levels of depression, against the IQ. Now we want to know, or want to find out, if depression has any significant effect on the IQ of the women. So our null hypothesis here state that there is no significant difference in intelligence score between the levels of depression. In other words, you can say that depression level does not have a significant effect on intelligence score, which is also known as the IQ. So we can also think of it, if you are depressed, how does depression affect your IQ? Does depression actually have any significant effect on their IQ? So that is the structure of this analysis now, is that you are analyzing a continuous variable, which is IQ, continuous variable, against depression. Depression is a categorical variable that has 4 groups. Yes.
That is ordinal.
Yes, ordinal categorical variable that has, it's not even ordinal. Yes, ordinal, yes. That has up to 4 different groups. So I told you that to analyze such a relationship, you are going to deploy ANOVA, because ANOVA is used to analyze this situation where you have a categorical variable that has more than 2 groups against a continuous variable, IQ. So ANOVA is used to test the mean, to test whether the mean of 2 or more groups differ on a continuous dependent variable. What ANOVA actually does here is to test whether the mean intelligence score differs on this group, these 4 groups here, on a continuous dependent variable, which is IQ. So to do that, the Stata formula, or the Stata command that you deploy, is ANOVA depression IQ. ANOVA depression IQ. So you are going to, first of all, ANOVA, then the categorical variable, and then the continuous variable.
Continuous variable. Okay, sir. Sorry, in this case, but the categorical variable, it just has to be a categorical variable with no, will I say, we're not giving any special regard to whether it is ordinal or nominal. What is important is that it just has to be a categorical variable with more than 2.
Yes, categorical variable with more than 2 groups. Whether it's
we have, whether it's ordinal or
nominal.
It has no importance this time around.
No, it has. It has.
Okay.
And yes.
Okay.
So now we also use another command here. So we also use another command here to do the descriptive statistics. We have tabulate depression, summarize IQ in parentheses. So I'm going to take you over to Stata so that we deploy this. Let me go to Stata right now. So if I say ANOVA depression IQ. So this is my output here. ANOVA depression. I'm going to have this. So let me take you back to Excel where I have shown it. Now look at it. Now look at the output of the ANOVA here. So you can see the output here. We have the p-value. We have the F. The p-value is here. The p-value here for the model is 0.3832 with F statistics of 1.20. Now, our p-value will determine if we are going to accept or reject the null hypothesis. The p-value is very important here because we are going to use it to accept or reject the null hypothesis. Here, I have here that since the p-value of 0.3832 is greater than 0.05, we accept the null hypothesis that depression level does not have a significant effect on IQ. So our p-value is actually greater than 0.05. Our p-value is greater than 0.05. So we also have other distance here which are not very much relevant in our interpretation. We have the F statistics, which is this value here. The F statistics tells us how jointly significant the independent variable are in predicting the dependent variable. So the higher
which of it is the F statistic?
Look at it
from
here.
the
Look at it here. F
1.28.
1.28, yes. So
okay, and why is it the same as both for model 1 and IQ? The figures are the same. Is it usually the same?
That's the dependent variable now. That's the dependent variable we are interested in. It's the same.
Okay.
So here now, the higher the F statistics, the better the model. You know, the F statistics here tells you how jointly significant the independent variable are in predicting the dependent variable. If we have a significant p-value here, the F here will be higher. For example, if there was a significant effect, that means if the independent variable had a significant effect,
yes,
our p-value would have been lower than 0.05, isn't it?
Yes. And then the F statistic will be higher.
Yes, F statistics would have been higher. So is a determinant of how significant the variables and the independent variables are in predicting the dependent variable. So that's the only this. And then we also have the R square tells us the total variances in the dependent variable that are explained by the independent variable. Now we have R square here of 0.6461. Now this parameter here actually determines the level of effects the independent variable had on the dependent variable.
Okay.
Now is that what it means now is that the depression level had about 64.6% effect on IQ.
Okay.
Yes, because this is now 0.6461, you multiply by 100 by percentage. So this is going to 64.6%. So you can say that the changes that occur in the dependent variable, the changes that occur in the dependent variable is as a result of 64.4% effects on from the independent variable. So in essence, you can say that the independent variable depression level had 64.6% impact on IQ. So that's what that's the level of that's what the R square is letting us know. So we also run the descriptive statistics using the second command, where we have this here. You can actually see the descriptive statistics that we have the none for depression, none, mild, and moderate. So none had a mean IQ of 92. Then while the mild has 90, moderate has 82. So that's why you see that there is no significant difference. So people that are not depressed has 92% and 92% IQ. Right?
Yes.
Why the women that have mild depression have 90%? The ones that have moderate depression have 82%. So if you look at these numbers, you see that they are very close to each other. That is why our p-value is not significant. The p-value here determines if there is a significant difference in this thing here, right?
Okay.
So
yes,
people that does not have depression are not very far from people that have mild.
Okay. So, okay. Also, how do we determine our dependent variable?
Huh?
How do we determine our dependent variable?
Okay. Yeah, the dependent variable here is the IQ. Now we want to, from the beginning we were looking for how the categorical variable is the independent variable. Let me just say it like that. The categorical variable, the depression.
Okay.
Depression, which is the categorical variable.
Yes.
When we are running ANOVA, the categorical variable is the independent variable.
Okay.
While the continuous variable is the dependent variable. That's why we say here ANOVA is used to test whether the mean of two or more groups differ on a continuous dependent variable. Continuous.
Okay.
So your continuous variable is your dependent variable.
Okay.
Which is your IQ, while your group variable is independent variable.
Okay.
Yes.
Okay.
So you can see even if you in real life you can also perceive it that depression can also affect people's IQ. Are you there?
Okay. Yes, I'm with you.
Yes, if you are depressed, it has the tendency of affecting your thinking faculty at least.
Yes,
Or
that's true.
your ability to think. So
Mm.
it is a dependent variable that will. So here now we can see also this place will also help us to, because as I'm explaining it here, this is how you are going to explain it in your interpretation of results.
Mm.
Are you getting it?
Yes.
So you are going to tell them that you also interpret your descriptive statistics that the women that have no depression have a mean IQ of 92. The ones that have mild depression have 90, moderate depression 82. So you see that it's actually not much difference between them. And
Mm.
that is why our p-value is also not significant.
Mm.
So that's why we actually accepted the null hypothesis that depression does not have a significant effect on the IQ of the women. So that is this. Okay, there is maybe you have to read up this one. The degree of freedom is a statistical concept that refers to the number of independent values or quantities that can vary in a data set or calculation without breaking any constraint or rule. Yes. So most of the time, the software does the calculation automatically. That's why we have our degree of freedom to be 17 here. Our degree of
Mm.
freedom is 17 here. Now, another thing I want to also point out here is the hypothesis number 6. Hypothesis number
Sorry,
6.
sir. Sir, we didn't do any we didn't use Stata to resolve any this thing, solution to regression to correlation.
I didn't get you.
We did not solve any problem for that of correlation.
Correlation, we have done correlation
We,
with
we
correlation.
just looked at it. We just looked at it from the slide.
Here now, this one we did last time is in the other video. We have done this
Okay, yeah.
pairwise correlation with
No,
3 of them. We have this one.
okay, yeah,
We have
it's
done this
true.
one already. I just explained it.
Okay.
This one, this is a formula. This is a command for correlation in Stata,
Okay,
and this is our output here.
yes.
So I just explained the one for weight and this, which is the same thing with this and this too. Regression here, we are going to deploy regression to answer hypothesis 6. What is the
Okay.
relationship? What is the relationship between age and IQ?
IQ. Mm.
There is no significant relationship between age and IQ. Now, why do I deploy regression analysis in this hypothesis? The reason is that age and IQ are both continuous variable.
Mm.
Age and IQ are both continuous variable. So correlation and regression analysis uses
Okay.
correlation and regression analysis uses continuous variable against another continuous variable.
Okay.
So anytime you are looking for the relationship between two continuous variables, and you want to predict the relationship in a straight line graph, you deploy regression analysis. Now, simple linear regression is used to model the relationship between a single response variable, also known as dependent variable y, and a single explanatory variable x, also known as independent variable. Now, the model is represented using y is equals to a plus b times x plus e. Now, this equation, if you did your basic mathematics, you will remember the straight line graph or the straight line equation we did in maths primary 4, primary 5 mathematics. So you will remember that y is your dependent variable here, and x is the independent variable. So x is going to predict y. If you know the value of x, you can predict the value of y. Now, the intercept here, the intercept, or also known as the constant, is represented by a. A straight line graph is always like this. You see a graph is a value predicted for a response variable when the explanatory variable takes the value 0. Now, b is a regression coefficient, also known as the slope. It is the change in the response variable predicted when the explanatory variable is increased by 1 unit. So, the b here represents the change in the response variable. I told you that the response variable is your y. B represents the change in the response variable predicted when the explanatory variable increases by 1 unit. So anytime x increases by 1 unit, what will be the value of y? So that is, how does y changes anytime x changes by 1 unit? So that is what the b here is going to represent.
Okay.
So what it means here now is that when you are predicting, okay, from here now, which one is our dependent variable between age and the IQ? Which one do you think predicts the other?
Between age and IQ? Is IQ.
Okay, IQ
is being used to predict the age.
No. IQ is the dependent variable. Is when you know the age of the students, you cannot predict their IQ. Sorry, when you know the age of the woman or the women, you can predict their IQ. So in this case, age is our independent variable, and the IQ is the dependent variable. So we examine whether age predicts the IQ of the psychiatric women. So I told you before that to deploy ANOVA, to deploy regression analysis, the two variables must be what? Continuous. Yes. In this case, we have age and IQ. So
my challenge is still the ability to determine which, in this case now, which of them is dependent.
Dependent is the Y, which is the IQ. You know, as you can see, I've already replaced IQ with Y. And age, we want to We want to predict the value of the women's IQ when we know their age. Yes. Age is the independent variable, the predictor on the x-axis. While Q is the dependent variable, the response variable on the y-axis. So that's why I replace IQ, I replace Y with IQ and X with age. So in this equation now, this is, so the intercept here, which is a constant A, and B is our regression constant. So this one is error, so is negligible. So the null hypothesis here states that there is no supported relationship between age and IQ. And the command, the Stata command for regression is regress IQ, then age. In this case now, you have to put the dependent variable first. You have to put the dependent variable first. Regress dependent variable, then independent variable.
Okay.
Yes. Regress dependent variable, independent variable. So that's how you put it. Regress IQ, age. So this one now, the positioning is very important here. If you put it the other way around, it will assume that age is the dependent variable, and you will get a wrong analysis. Because there is also multiple regression. Multiple regression is a situation where we have more than one independent variable. So,
okay.
Yes, more than one independent variable. That situation now, you're going to do regress IQ, then you list all your independent variable up to 2 or 3 of them. So, but in this case, this is a single or simple regression analysis. So let me take you to
Stata
to run the analysis. So if I say regress IQ, age. So you have your output here. So let me copy this to my PowerPoint to do the explanation. Now, in the PowerPoint here, you can see that we have about 3 tables in one here. We have one table here. We have another one here. Also have another one. Let me start with this one here because this is the important one. The important table here is where we have our coefficient, standard error, t statistic, and p-value. Now, we have our IQ here and age. This is constant. And this is our coefficient. The coefficient here is minus 0.4782. This value here is equivalent to the B in the formula. That B in our formula here is this particular number here, minus 0.4782. Then the constant, which is A, the constant, which is A, is 108.285. So what we'll do now is that we take these two numbers and substitute it inside that our equation. So when we do that, you see that, yes, you see that the regression coefficient, which is equivalent to B in the equation, is minus 0.47826. Now, what it means is that 1 year increase in age will result to 0.4878 units decrease in IQ of the women.
Okay.
Now, the negative value here, I told you anytime you see negative means that it is inversely proportional. That means if age increases by 1 unit, then IQ is going to decrease by this amount here, 0.47826 units. So for any time age of the women increases by 1 year, their IQ reduces by this amount, 0.47. Yes. The negative value indicates the direction of the relationship. Means if age increases, IQ decreases. Then you now go back, go to the p-value. The p-value of the t statistic. The p-value here is 0.05. I mean,
5.
0.005, which is less than the level of significant value of 0.05. This indicates that there is a supported relationship between age and IQ. It means that age had a significant effect on the IQ of the psychiatric women, which will now make us to reject our null hypothesis. So this is how you explain your regression analysis. All these things I'm saying, you are going to write it in your explanation, your output. Yes. You copy this to your work and you now explain all these things in details as I'm explaining it. You first of all start with the coefficient. The coefficient is the relationship factor. That is what determines if there is relationship. Okay, so you have that the p-value is also significant. That is why it is less than 0.05. So we can say that age has a significant effect on
IQ.
Yes, IQ. Then when you go to, if you also go and look at this other table here, you see that our R square or our F statistics is about 10. You see this one is high now, 10.77. I told you that the F statistics is what determines how significant the independent variable is in predicting the dependent variable. So you see that as the effect increases, the F statistics is also increasing. You know, we had 0 point something in the other one when we did an ANOVA, that we didn't have a significant effect. It was low. But the F statistics is high now, as you can see. Then our p-value, the overall p-value is also significant, 0.00, which is almost something with the 0.0045. Then our R square is here now. We can say that 40%, the variation in the dependent variable is as a result of 40% effect or 40.2% effect on the dependent variable. In other words, you say that the independent variable had about 40.2% effect on the dependent variable. That's what the R square represents here. The coefficient here is the estimate of the independent variable and the constant. It compares the estimate of intercept and the slope. So the sign of the coefficient also tells the direction of the relationship. Then we have the standard error. shows the deviation of the coefficient. It tells you how much deviation that occurred from the slope of the model. Then the t statistic, it means that the number of standard error that the coefficient is from 0. So here you can also compute the t statistical coefficient divided by standard error. Then our p-value helps you to reject or accept the null hypothesis. It tells you how significant the coefficient. The 95% confidence interval, this interval will always contain the coefficient if it is significant. Our test, we see that our p-value, our R square here is telling us dependent variable had impacts on the dependent variable. So we can say that the independent variable, which is age, has 40.2% effect on the dependent variable, and this impact is actually very significant, as you can see. So for every time age increases by 1 unit, then IQ will decrease by 0.4782 units will be decreased. So that's the interpretation of your regression analysis. So it's very simple. What you need to understand is your coefficients, your p-value, and your
dependent and independent variable.
Yes, the independent and the dependent variable. So here you are able to.
But for the coefficient, is the Stata that will calculate it now, if you do the right thing. I said the coefficient is Stata that will calculate it if the right thing is done.
Yeah, Stata calculates everything for you. Look at the coefficient is here.
So I still want to know more. I still want you to throw more lights on determining the dependent and independent variable.
Okay.
Especially, I was able to get it for ANOVA, considering that you said the dependent is going for continuous variable. The continuous variable automatically becomes the dependent variable in the case of ANOVA. But in this one, in the case of this one, I want to know what are the how do you determine the dependent and independent variable from one another?
Okay. Here, you are the one that is actually designing this research, isn't it?
Yes.
You are the one that is designing your research. Right? Which field are you?
Yes. I'm a scientist.
Of which side? Which?
Biomedical scientist.
Okay, biomedical, right?
Yes, I'm a life scientist.
Okay, right. Now, if you want to test the, let me get. If you want to predict the cost of malaria.
Yes.
Malaria.
Yes. Yes.
So, what are the things that can cause malaria?
Number one, stagnant water.
Which is
stagnant pool of water.
Which is what? Which is mosquito now? Contaminated water.
Yes. Yes. Then bushes, overgrowth of bushes.
Okay, let's say you are making investigation. You are making investigation to determine the possible causes of malaria in your environment.
Okay. Okay.
That stagnant water, mosquito bites. Let's just use mosquito bites and the malaria.
Okay. Yes.
So now, first of all, you are the one that formed the topic. The topic on effects of causes of malaria.
Okay.
Now you choose different variables you think that can cause malaria, is it not?
Yes.
Yes. So from that moment, you already know that the predictor of malaria is what? Mosquito bites. Right? So
Yes.
mosquito bites is your predictor, which is your independent variable. Why malaria is your what? Is your dependent variable.
Dependent variable.
Yes.
Okay.
So the one that is causing the effects on the other one.
Yes.
Yes. The predictor is the one that causes the effects, and that is the independent variable X.
Okay.
Yes. That's independent variable X here. So the predictor.
Then the cause.
The cause, yes, the cause and the effect, the cause and effect. So why this one is that predictor now is also known as the independent variable or the explanatory variable.
Okay.
Yes. Then
okay.
The one that is receiving the effect is also known as the response variable. How does it respond? So it is
the outcome of the other one.
Yes, it is it's going to respond to the effect of the other one.
Okay.
So that becomes your Y, which is your malaria, which is the one you are interested in. In that your research now, you are interested in your malaria, is it not?
Yes.
Now you want to now know if how does stagnant water or mosquito bites cause malaria? How does it affect this? So that is how you know the dependent and independent variable.
Okay.
Because anytime you are talking about relationship between two continuous variables, you must visualize it to know the one that is actually affecting the other.
Okay.
Yes. So you must determine that first in your research before you start.
Okay.
Yes. That's how you must make that
discrepancy.
Yes, before you start for you to even choose your topic, you need to know which one is going to affect which one.
Okay.
If I'm doing a research on the effect of foreign exchange on economic development, people in management sciences,
yes,
of foreign aid, effect of foreign aid on economic development, which is our GDP. So you can use GDP as your Y, which is going to have the dependent variable now, right?
Yes, that's true.
You now use economic
foreigners.
This foreign aid as your X.
Okay.
Yeah, so you are supposed to determine that from the beginning.
Okay.
So and you know that you do all these things in your chapter 3. Chapter 3 is where you are going to put all these your models down, how you are going to do your analysis. Okay. So you write down all the this thing that you need to you have formula. By that time, you should have been able to know which one is which, especially when you are working on regression analysis.
Okay.
Yes, but for ANOVA, it's very easy. The ANOVA is the group variable, the differences in the group. How does the differences in the group affects the continuous variable.
Okay.
Yes, so the continuous variable is the dependent variable, while the factor or the group variable is the independent variable, which is causing the effects.
Okay.
Yes.
What's the major difference between regression and correlation?
Huh?
Because if you look at it, the factor for doing them,
Mm.
both of them deals with continuous variable.
Mm.
So, what informed the decision of when to use either of them?
Which one and which one?
Regression and correlation. Both of them use this continuous
Variable.
compared to relationship between two continuous variable.
Yes.
So how do you determine the choice of which is to be used for an analysis?
Okay. You are this in.
How may you see a question, then you now know that okay, this question now I think is preferable to use a regression or to use correlation.
Okay. You know, when you have correlation is used when you want to determine, when you want to test if there is a relationship between two continuous variables. If you are just looking for if there is a relationship and also the strength of the relationship, right? If there is a relationship, if relationship exists between the two continuous variables, and if it does, what is the direction of the relationship and what is the strength of the relationship? That is what correlation does for you. But when you want to now look at the magnitude of effects that the independent variable had on the dependent variable, and also to predict, for example, here, you can predict IQ now when you know the age of the woman. So when you want to develop a relationship model, you use the regression analysis. It does more than correlation. Correlation will only give you if there is relationship, the direction of the relationship and the strength of the relationship, either weak or strong relationship. It doesn't go deeper to tell you the magnitude of the effects.
Yes.
Are you there?
Okay.
Yes,
I'm with you.
And it doesn't go deeper to telling you the magnitude of the effects. Here now we can say that 64% impact. This one, the independent variable had about 64% impact on this. Right? Now, yes. You also, in regression analysis, you develop a relationship model to be able to predict the dependent variable too.
Okay.
So if one variable predicts another in a relationship, then you want to use regression analysis. But if you just want to show their relationship and the strength of the relationship, you can just use correlation analysis. So most people use correlation analysis in social sciences. They use, some universities use correlation analysis. I'm going to teach you some graph by our next class.
Okay.
Yes, how to plot one or two graphs, because all these ones we are supposed to get maybe the scatter graph and some of these small graphs.
Okay, sir.
So we'll do that one tomorrow. Then maybe we can summarize tomorrow, hopefully.
All right, sir.
Thank you.
Thank you, sir. Have a nice time.
All right.